Hello everyone, my name is Pritesh Gamit and today we are going to discuss a very simple question based on DC to DC buck converter. So here we have battery pack at 48 volt and we have to supply a load at 12 volt and the load current is specified as 5 ampere. So here we have sub question. So we have to find out first duty cycle of that converter, which is very simple thing, and switching frequency of the converter. So we have to just suggest one switching frequency for that buck converter. And here we have C and D is our main part. Here we are going to determine the value of inductor such that the current is continuous and the inductor current ripple is less than 30% of average inductor current. And after that, the another important element is the capacitor. So we have to determine the value of capacitor such that its voltage ripple value should be less than 5%. So here we have a buck converter. Here full waveform is given for on and off period. So here we have buck converter with L, C and R component. After that we have some given data. So here we have battery voltage VD is equal to 48 volt and we have to supply at 12 volts. So it will be step down and the load current is specified in the question is 5 ampere. From the based on the given data we can calculate the resistance value, load resistance value, which R is equal to V by I. So we will get the 2.4 ohm. Let's find out the duty cycle. The simple relation for the duty cycle for buck converter is V output is equal to duty cycle into battery voltage. In the given data, we have voltage output and voltage input. So we can calculate the duty cycle, which is 12 divided by 48 is equal to 0.25. Next thing is suggesting a switching frequency. So before deciding the switching frequency, we have to consider some parameter. So the size of the inductor and capacitor is depend upon the switching frequency. The higher the switching frequency, smaller the inductor and the capacitor size. And we have to also consider the switching losses in the power electronic switch. So higher the switching frequency, higher the switching losses. So based on these two parameters, we can decide the switching frequency of the converter. Here we have taken the switching frequency as 50 kilohertz. Now let's begin the main part of our question, which is designing the L. In the question, it is mentioned that design an inductor such that the output current is continuous, ripple current is less than 30%. So here we have to consider on and off period in order to determine the equation of inductor. During the on period, the inductor voltage will be VD minus V naught. VD is nothing but the battery voltage and V naught is equal to output voltage, which is clearly seen from the circuit diagram. And we can also say that the inductor voltage is VL is equal to L DIL by dt, where DIL is nothing but the change in inductor current, which is mentioned. So comparing both the equation, we will get the equation shown on the screen. So we have to find out the inductor L. So we will make subject L and that's the equation to find out the inductor value. So putting all the values from the given data, we can determine the value of inductor, which is 120 microhenry. And to keep the ripple value below 30%, we can take increased value of inductor, which I have taken as 150 microhenry. The next part is to determine the value of the capacitor. We may know the simple relation between voltage, charge and capacitor. So here we will take delta V naught is equal to delta Q divided by C. Here we can find out the delta Q using the waveform. Let's see the waveform. Here we have inductor voltage, inductor current and output voltage. During the on period, the inductor current will be increased till the peak. After the off period, it will decrease till its minimum point. So during the positive half one, during the charge and discharging above the positive line, capacitor will charge. In that period, we will have switching frequency divided by 2 and the height of the triangle is delta IL. So we can find out the area for the delta Q is equal to 1/2 TS by 2 into delta IL by 2 using the area of triangle equation. After putting the value, we can get the values, get the equation like that, and making the subject capacitor to find out the value of the capacitor. We have delta IL, switching frequency, and voltage output ripple. After putting the value of all the data, we can find out the capacitor value, which is 6.25 microfarad. To keep the ripple value less than 3%, capacitor must be chosen greater than that value. So we will take the value of capacitor 7 microfarad. We will check all that value in the simulation and verify all the theoretical value through MATLAB simulation. So it's the simulation time. We will discuss the simulation of that converter in part 2. Thank you.